Assalamualaikum and hi everyone. My name is Daniel Iqmal. We are from Group 4 and today we will be presenting our mini project for the course EDJ 22503 Electrical Installation Design. Alright, now we go to the introduction to the project. First, the foundational principle. Electrical installation design is very important to ensure safety, efficiency and long-term reliability in a building. A well-designed system helps prevent electrical hazards such as overload, short circuit, and poor illumination. It also ensures optimal performance of the entire electrical infrastructure. The second one is the role of lighting. Lighting is not only about providing brightness. Proper lighting improves comfort, increase productivity, and enhance safety. Good lighting design reduces eye strain and improves task performance, especially in educational or office environment. The third one is consequence of poor design. On the other hand, poor lighting design can cause serious problems. These include high energy consumption, frequent maintenance issue, uncomfortable working condition, and even unsafe environment. Therefore, proper calculation and planning are essential to avoid these risks. And the last one is for this project focus on JHAP building. For this project, we focus on designing a complete fluorescent lighting system for the two-story JHAP building. We apply theoretical knowledge we have learned in class into a practical real-world scenario to meet operational requirements. Alright, now we move to the project scope. Our project covers a detailed fluorescent lighting system designed that ensures both functionality and compliance with industry standards. There are 5 main components in our project scope. The first one is system design. First, system design, we design the fluorescent lighting system based on the specific requirement of the JHAP building. This includes considering room function, layout, and user need to ensure proper illumination. The second one is lumen calculation. We use the lumen method to calculate the required illumination level for each area. This helps us determine the correct number and placement of the luminaire to achieve adequate lighting. The third one is AutoCAD layout. We develop a detailed lighting layout using AutoCAD to clearly show the luminaire position and electrical pathway. This ensures easier installation, maintenance, and future upgrade. The fourth, load and protection. We perform load calculation and select appropriate protection device such as MCB and RCCB. This ensures the system is protected against overload and short circuit. Finally, compliance adherence. Our design follow national and international standards, including JKR Electrical Installation Standard, IEC Standard, and IEE Wiring Regulation BS 7671. This guarantees safety, quality, and regulatory compliance. I think that's all for me. Thank you.
Thank you, Daniel Iqmal. So now, I will continue the presentation. My name is Muhammad Azim bin Shaharuddin. For my part, I will present or explain about the objective of the project and standard and reference that used in our project. Project objective. The core objective of this project are centered on delivering a lighting solution that is not only functional and efficient, but also adheres to the highest safety and design standards. First, design a compliance system. to meticulously design a fluorescent lighting system that fully complies with all relevant electrical codes and safety regulations, ensuring long-term operational integrity. Second, calculate luminaire needs. To accurately calculate the precise number of luminaires required for each room within the JHEP building, optimizing for both light distribution and energy efficiency. Third, ensure uniform lighting. To create a lighting layout that provides uniform and comfortable illuminations throughout the space, minimizing glare and dark spots to enhance user experience. Fourth, determine loads. To meticulously determine the total circuit load TCL and maximum demand MD for the entire electrical system, a critical step for proper circuit design and component selection. Select safety device. Number 5. To carefully select suitable miniature circuit breaker MCB and residual current circuit breaker RCCB to ensure the highest level of safety and protection against electrical faults. The next slide, standards and reference use. Our project rigorously addressed a comprehensive set of national and international electrical standards to ensure the highest level of safety, quality, and performance in the lighting system design. JKR Electrical Installation Standards. These are the fundamental guidelines set by the Jabatan Kerja Raya Public Works Department for electrical installations, ensuring compliance with the local regulatory requirements and best practice in Malaysia. IEC Standards. International Electrotechnical Commission (IEC) standard provide globally recognized benchmarks for the electrical, electronic, and related technologies, ensuring interoperability and safety across various systems. For IEE wiring regulations, the Institution of Engineering and Technology (IEE) wiring regulations define the requirements for electrical installation in the UK and are widely adopted internationally for their comprehensive safety provisions. For illuminance levels, we recommend illuminance levels for different special applications, ensuring that each area of the building receives appropriate and comfortable lighting intensity for its intended use.
Assalamualaikum, my name is Muhammad Adamari bin Zamzuri. Today I will talk about fluorescent lighting system overview. Fluorescent lighting remains popular and practical choice for many commercial applications due to its distinct advantage in performance and cost effectiveness. Widespread use. Fluorescent lights are extensively used in commercial buildings, including office, school, and retail spaces, owing to their versatility and efficiency. Energy efficiency. They offer good energy efficiency, converting a significant portion of electrical input into visible light, which helps in reducing operational costs compared to incandescent option. Color rendering. Fluorescent lamps provide acceptable color rendering, making them suitable for environments where accurate color perception is important but not critical, like general office work. Cost effective. The moderate installation costs combined with lower energy consumption make fluorescent system a cost-effective lighting solution for large-scale deployment. Versatile application. They are particularly well suited for space requiring consistent diffuse light over extended period, such as office, corridor, and various workspace. Next, we have methodology overview. We have study layout, determine illuminance, perform calculation, design layout, and calculate load and protection. Our project employs a systematic methodology ensuring that every aspect of the lighting design is thoroughly addressed, from initial building analysis to final protection device selection. Lighting calculation method. The lumen method is a widely accepted and efficient technique employed for calculating general illumination level in an indoor space. This method provides a reliable estimation of the total luminous flux required to achieve a desired average luminance. Room area consideration. The calculation starts by taking into account the total floor area of the room to be illuminated, as larger spaces naturally require more light sources. Lux requirement. The desired illuminance level measured in lux is a critical input which varies based on the function of the room, for example, office, corridor, storage. Excel for precision. All calculations are meticulously performed using Microsoft Excel, ensuring accuracy and facilitating easy adjustment and optimization of the design parameters. Uniform illumination. This method ensures that the design lighting system provides sufficient and uniform illumination, eliminating dark spots and reducing glare, thereby creating a comfortable visual environment.
Thank you, Adam. My name is Muhammad Hamzah Muslim bin Abdul Samad. I will continue the presentation. Lighting layout design. AutoCAD precision. The entire lighting layout is precisely designed within AutoCAD, allowing for accurate positioning of each luminaire and detailed representation of the electrical circuit. Symmetrical arrangement. Luminaires are arranged symmetrically to ensure an even distribution of light across the entire space, preventing uneven illumination and enhance the aesthetic appeal of the ceiling. Optimal spacing. Careful consideration is given to the spacing between luminaires to avoid the creation of dark spots and to minimize glare, which can lead to visual discomfort and reduce productivity. Maintenance accessibility. The layout also incorporates principle of easy maintenance, ensuring that luminaires are accessible for cleaning, lamp replacement, and servicing without significant disruption. Load distribution concept. Logical grouping. Lighting circuits are meticulously grouped based on area of function, creating a rational and easy to manage electrical system for the building. Overload prevention. This strategic grouping prevents individual circuits from being overloaded, a common cause of electrical fault and system failure, by distributing the load evenly. Ensure safely. Proper load distribution significantly improve overall system safety and reliability, reducing the risk of fire hazard and equipment damage, thus protecting occupant and asset. Simplify maintenance. A well-organized load distribution concept streamlines maintenance and troubleshooting effort, allowing technicians to quickly identify and address issues, minimizing downtime.
Assalamualaikum and good day. My name is Akmal. I will be representing the discussion and conclusion for Part A, which focus on the lighting design for the two-story JHAB building. Okay, for the project discussion part, lighting design, the first one is illuminance standard met. The proposed fluorescent lighting system meets the recommend illuminance level based on JKR electrical installation standard. The second one is accurate lumen method application. The lumen method was applied using Microsoft Excel to determine the required number of luminaires for each area. The third one is optimized lighting layout. AutoCAD was used to produce a symmetrical lighting layout with proper spacing to be reduced dark areas and glare. And the last one for the discussion is safe load distribution and protection. Load calculation confirm safe operation with suitable MCB and RCCB, selected in accordance with IEC and IEE wiring regulation. And the next part, we move to project conclusion for lighting design part A. And the first one for the conclusion is objective is achieved. A complete lighting design was successfully developed according to project requirement. The second one is systematic design approach. The design apply Lumen method, calculation, layout planning, and load analysis in an organized manner. The third one is safety and compliance. All protective device comply with JKR, IEC, and IEE standard. Then the last one is future application. The design provide a foundation for future electrical design stage. And that's all for me. Thank you.